In this problem, I'm asked to multiply and simplify the square root of 6 times the quantity 5 times the square root of 3 plus the square root of 2. So the way I'm going to do this problem is I'm going to distribute the square root of 6 into this parentheses. So what I'm going to get is the square root of 6 times 5 times the square root of 3 plus the square root of 6 times the square root of 2. So in looking at this first term, I have a mixture of numbers that are outside the square root and numbers that are inside the square root. So remember, when I have the square root of 6, it's just the same as writing 1 times the square root of 6. And when you're multiplying terms that contain numbers outside and inside, it's basically the numbers that are outside multiply together and they will stay outside. So I have 1 times 5 is 5. So that is going to stay outside the square root. And then I'm going to take the numbers that are inside the square root or under the radical, and they're going to multiply together and stay inside the square root. So I have the square root of 6 times the square root of 3. 6 times 3 is 18. It's going to give me the square root of 18. Now on this last term, I just have the square root of 6 times the square root of 2. So I'm going to have plus the square root of 6 times 2 is 12, and it's going to stay under the radical. So now I've distributed in the square root of 6. All I have to do is simplify my answer if possible. So let's look at 18. Can I factor that? Yes, it definitely factors. There's different ways to do it, but the first thing I notice, it's 2 times 9. 9 is a perfect square, so I don't have to factor it anymore. I can write my square root of 18 as the square root of 9 times 2. Plus, now let's look at the square root of 12. 12, let's see if we can factor this. Oh, let's say it's 2 times 6. Are either of those perfect squares? No. 6 is 2 times 3. So now, these together make a perfect square. So 2 times 2 is 4, times what else is left over? A 3. Double check, does 4 times 3 equal 12? Yes. So now, I can use the product property of radicals to write this as 5 times the square root of 9 times the square root of 2 plus the square root of 4 times the square root of 3. So this equals 5 times, what's the square root of 9? 3 times the square root of 2 plus the square root of 4 is 2 times the square root of 3. Last step, 5 times 3 is 15 times the square root of 2 plus 2 times the square root of 3. Can I add this term to this term? No, because the radicands are different. You cannot add a square root of 2 to a square root of 3. So this is my answer. I wanted to point out just a couple of things here. In doing this problem, I wrote out every single step. After a while, you won't need to write out this step, and you won't need to write out this step. But I put them all in for clarity. The other thing I wanted to point out is when you're factoring numbers, there are a lot of different ways to factor it. But as long as I land up at the same answer, it doesn't matter. So the square root of 18, instead of saying it was 2 times 9, I could have said it was 3 times 6 and then worked with that, but I would have still landed up at this point here.